let's understand now what we have in front of us here. So it's giving us that f is a continuous function from -3 to 3, whose graph consisting of, and this is key, 3 line segments. So these are lines. So it's a straight line, basically 3 line segments, and a semicircle centered at the origin. And this is also key, the semicircle aspect. Okay, let g be the function given by g of x is equal to the integral from 1 to x of f of t dt. So they're giving us an accumulation function where they give us the original function and they're integrating. They're saying 1 to x. And they want us to determine some values for this accumulation function to start. So let's start with that. G of 2, by definition that they gave us, g of 2 is equal to the integral from 1 to 2 of f of t dt. And I just need to look at this one. This is a fairly straightforward one. I want to find out the integral from 1 to 2. So here's 1, here's 2. The integral from 1 to 2 is exactly this region right here. Make sure we know that we want to find the area and make sure that it's negative, whatever it is. So I want to find the area of that region. It's going to be negative because it's below the x-axis. The key here is really just to know how to solve for that height of this triangle, I guess you should say, or whatever the base, I don't know, the width or whatever, or yeah, the height, I guess, in this case. But we should remember that this is a line segment, so this is a straight line, right? And it goes down to -1 right here, right? So if it goes down to -1 right here, I'd have 2 points on my line. I could simply just find out what the equation of that piece of that line is and plug in 2 to find out that this is exactly 1/2. Or you could do some logic and you could figure out that this length is 1/2 and this is at -1/2 right here. Okay, it's up to you. Be sure to conclude that this length is 1/2. Then once you have that, then you know this length is from 1 to 2, it's 1. So this area here is 1 times 1/2 divided by 2 is 1/4. And my first value, g of -2, is -1/4. That's to start. Now, g of -2, you need to know a little bit extra for g of -2. Using the definition, I go from 1 to -2 of f of t dt. And then now the little bit that makes it a little bit easier, you could just start computing what that is by going backwards from here and just knowing that it's going to be negative. I think it's a little bit easier if I write it as negative and I swap the bounds out because I don't like integrating backwards. -2 to 1. So -2 to 1, this is -1 right here. This is -2. I want to find out what this integral is all the way to here. So I'll put that in, I don't know, orange. So here's this color. I'm finding out what this area is. Then I'm going to subtract out this semicircle area right here. And that's from -2 to 1 of f of t dt. And I just got to remember to make it negative at the end. So what is this integral? Let's find out what this part is here. Just this. What's this integral? So this integral, right, this with this triangle here, this base is 1, and then this height is 3. So this becomes 3 times 1 over 2. So that's 3 over 2. And then I want to subtract out the area of this semicircle right here, and I'm going to make the whole thing negative. I'm just doing this first, like as I see it, as I go here. So what is this? Well, what's the radius of this semicircle? The radius of the semicircle is 1, and the area of a circle is pi r squared, and then the area of the semicircle is exactly half that. So it's pi r squared over 2, and the radius is 1, so then that means that this area is pi by 2. And I want to subtract out that pi over 2, and then I want to make the whole thing negative. This is going to give me as my final answer pi minus 3 over 2 as g of -2. So yeah. That's the next one, whatever that value may be. And now, okay, now we're done with A. So that's it. That's just interpreting the accumulation function and knowing that when I swap out bounds, I make it negative. Or if you integrate backwards, you got to make it negative, whatever. Now, C. C involves a little bit more. We need to remember certain aspects. So we want to find the x coordinate. So it asks us for two things, right? So the first part of this is that it says find the x coordinate of each point. So we want to find all the x coordinates at which the graph of G has a horizontal tangent. And remember, horizontal tangent line means slope of tangent line is 0. So I want to find all the x values where the slope of the tangent line is 0 of G, right? Now, in this case, we need to remember that if I want to be talking about the slope of the tangent line, right, that's equal to G prime of x. And now I need to remember that the fundamental theorem of calculus, that G prime of x is equal to, if I just plug in x in for t here, f of x. And I know what the graph of f of x looks like. So the slope of the tangent line for G, right, for G is the derivative of G of x, right? So now I know the derivative of G of x is f of x. And I want to find out when is it 0, right? So I want to find out when is it that G prime of x equals 0 is when f of x equals 0, right? F of x represents the slope of the tangent line for G. I want to find out when G is horizontal, when the slope of the tangent line has a horizontal tangent line. That's slope of tangent line is 0. And G prime of x is just the slope of the tangent line, right? And G prime of x is f of x in this case, which is what they gave me right here. So I want to find out when f of x is 0. And I just look at this graph and I say, well, f of x is 0 at negative 1, when x equals negative 1, and when x equals 1. That's the only time that this curve hits the x-axis. So when x is 0, when x is negative 1, and when x is 1. That's the first part of this question. It asks me, find the x-coordinate of each point at which the graph of G has a horizontal tangent line. Again, if I'm talking about the tangent line, the slope of the tangent line for G is G prime of x. To get G prime of x, I need to remember the fundamental theorem of calculus, that G prime of x is just f of x, right? I plug in x for t here. And then now I know that f of x looks like this, which is G prime of x. This represents the slope of the tangent line for G. So the slope of the tangent line for G at negative 4 is 1. The slope of the tangent line is 1 here for G. The slope of the tangent line for G is 3 here. The slope of the tangent line is 0 here. The slope of the tangent line is 0 here. The slope of the tangent line is negative 1 here. The slope of the tangent line is negative 1/2 here. The slope of the tangent line is negative 1 here. Now I want it when the slope of the tangent line is 0, because that is horizontal. And the 2 points where that's true is x equals 1 and x equals negative 1. So x equals 1 and x equals negative 1. That's what it says. Find the x-coordinate of each point. I found the x-coordinate for each point of which the graph of G has a horizontal tangent line. I'm done with that first part. Now, for each of these points, determine whether G has a relative minimum, relative maximum, or neither a relative minimum nor a relative maximum. Now, what's key here is we need to remember that if G prime of x is positive, then G is increasing. And if G prime of x is negative, then G is decreasing. And with these two facts, I'm just going to give you a rough sketch of how we can look at this. So I want to determine, I want to determine what's happening here. So let's look at what G might look like given G prime of X. So this is G prime of X, right? This curve here, right? What could G be looking like? Well, here, G prime of X is positive. It's positive all up to this point. So if G prime of X is positive, G is increasing. So that means G is increasing, 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 until it comes to this point right here. Then G prime of X goes negative, and that means that G is going to be decreasing, 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 all the way to this point where it flattens out. It goes to 0, the slope of the tangent line, right? But then it goes right back to being negative, so that means G must be decreasing again. And this could be a rough sketch of what G looks like. I mean, I have no idea. It could be shifted in any which way. But the point is that you want to determine whether G has a relative minimum, a relative maximum, or neither at these points, at x equals 1 and x equals negative 1. So at this point, right, it went from being positive, increasing, 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 and then here you should see that it goes negative. So when it switches from positive to negative, that's a local max. And you should see how I justified that with my picture, local max. Okay? And now it went from decreasing, decreasing, decreasing to then decreasing still, right? It was decreasing before 1 and it was decreasing after 1. So before 1, it's decreasing, but here it was increasing. Anyway, but yeah, it's decreasing, 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 and then it still decreases. It flattens out. So this is, we say, neither. If it went from decreasing to increasing, then it would be a local min. This is neither. Where do we have it? How do I spell neither? Neither. Neither. And then that'll give you your answer for part C.